Okay. Hey everyone, I'm Amr Ramadan. I'm a site reliability engineer at Paycom, and today we're gonna talk about today is week two of the Python Lizard class, and we're gonna talk about like data structures and some of the common data structures that you would be using. Uh, you all can hear me, like the audio's clear and everything's clear, right? Okay, awesome. So first, if you have any questions, feel free to stop me. If you have questions outside of the slides, also feel free to uh, shoot the question in the message or just say it out loud. Uh, okay, so first thing is the list. It's probably one of the common data structures that you're gonna use, and the main things the main thing of a list that you need to focus on is that it's mutable. Mutable means that you can change the value of the index. We're gonna have some examples in the next slide. And these slides were prepared by Tom, one of the other mentors, so shout out to him. Um, so one of the main things of the list that are mutable means that you can change the value of the index in the list and usually, oh, sorry. So resizing the list is basically an O of n when you want, like say you have a list of size 5, you want to add one more element. In order to add that element, the time complexity is O of n because you basically have to create a new list which happens dynamically when you using the append function, which is what we're going to discuss in the next slide. Um, there's a method called length that you can utilize to get the length of the list. And basically, this is you pass in the index in order to access the value of that of the list at that index, and it's zero based. So you start zero, one. So if you have a list of size 5, it's gonna start from 0 till 4. Um, yeah, I think that's it for this slide. Let's move on to the next slide. Uh, So these are like some common methods or some common functions that you'll probably use in with a list. So you start at like my list is has three elements, one, two, three. If you want to append and like meaning and adding another element to the list, you would use the append method. So let's say you want to add four, the list is going to be one, two, three, four. Uh, Usually when you use the append function, and not usually, it's always like that. Like when you use the append function, it adds the element at the end of the list, right? So if the list was like, so if you want to add another element after the four, you would have one, two, three, and one, two, three, four, and then that whatever element you want to add. And let me just show you an example because I think that's so. Okay, let me comment that one out. Okay, so we have the list one, two, three, four. We're gonna append uh, four, so it's gonna be, let's see if we append it, the list becomes one, two, three, four, right? You add another element, so my list, then let's say you wanna append 10, and you print the list now, you will have one, two, three, four, and 10. Hopefully that makes sense here. Let me jump back to the slides. So that was one method that you can utilize. There's several other methods. Like this is the insert method here. It takes two arguments. The first argument is um, the index. The second argument is the value that you want to add. So at index 1, you want to add the value 1.5. So it would be, so you would find index 1, which is here, and you would add 1.5. And then the rest of the list would be the same, right? So the list originally is one, two, three. you added 1.5, so it became 1.5, 2, and 3. Extend is kind of similar to append, but you're adding a list to a list. So you have a list of 4 and 5, multiple numbers, and you want to add it to the original list, which is my list. So it becomes 1, 2, 3, 4, and 5. Here we have the remove method, which basically removes the index. So you pass in the index. Actually, sorry, it removes the value. Yeah, it removes the. Let me double check. So if you don't know, if you forget or anything, you just type in the my list, and then you type in the remove, and it's gonna tell you what exactly it's removes. Okay, so it actually, if you see here, it says remove first occurrence of value. So if you the value that you're gonna pass, it's gonna find it, and it's gonna. So in here, if I wanna add another value, let's say I wanna remove 2, it's gonna go through the list. It's gonna find the first 2. It's gonna remove it. So the list should become 1, 3, 2, 3. We print it, my list. Yeah, so it became 1, 3, 2, 3, and then 4 and 10. So we removed the first occurrence of the value. So you don't really need to memorize like what does this do or anything. If you're always at doubt, like I just forgot what it if it removes the value or removes the index and actually removes the first occurrence of a value, right? You can always check or you can just Google it, right? And you would get the answer. Uh, what else we have? Yeah, so the pop function, it removes the last element in the list. So it's always going to remove whatever the last element is in the list. And pop 0 removes the first element in the list. So pop, if you don't pass any argument to it, by default, it's going to remove the last element. If you pass in 0, it's going to remove the first element, which is at index 0. Um, clear, yeah, clear, I think removes everything in the element. Yeah, it does. So for pop, the list is going to be 1, 2, and then pop 0, you're going to remove the first index, so it's going to be 2 and 3. Um, you all can see my cursor, right? Just want to confirm that.
Yes.
Okay, awesome. Cool. Uh, what else do we have? Okay, sort function. The sort function here uses, as far as I remember, it uses two sorting algorithms. So it's like more of a hybrid sorting algorithm. And I think the time complexity of it is n log n. And always if you're a doubt, like you can always Google if you can say Python dot sort time complex, because that's usually a question that you would wanna. Yeah, it's all n log n like I mentioned, and it uses two types of sorting algorithms. Let's go back to the slides. And okay, and so you can pass in the reverse equals true. It's gonna sort the elements, and if you want it in descending order, like from the largest element till the smallest element, you can pass in the reverse equals true, the flag, and it's gonna sort it in descending. So the list becomes 3, 2, 1. Uh, there's like a lot of methods. You can definitely, these are like links to the Python documentation that you can always utilize to discover more. Um, if I'm going too fast, just feel free to pause me. Okay, next thing we have is the tuples, and they are, I think the main thing here is that they are immutable, right? Immutable means is you cannot change them after you initialize them. So like I was mentioning earlier, you can change the element. So if you can, for the list, you can change this one, you can change it to any other value. But for tuples, you cannot do that. So and you cannot increase the size. So they are immutable. They are a fixed size array. And so there's no resizing mechanism. Uh, they have also their operations that you can use same as the lists. Uh, yeah, that's everything on tuples. And that's another data structure. So every data structure that uh, you can utilize in different things, right? You're like the examples that we have here are very simple, right? But this is not the intention or this is not the end goal. This is probably that a step that you're gonna utilize in your code to achieve something. But definitely this is not like the end goal here, right? And next up we have the dictionaries, which is basically a hash map. It's like a key value pairs. It is a key value pairs actually. Um, and they're mutable. Mutable again means that you can change the values after it gets assigned or set. So a dictionary would look something like this. The key is always here. Like this is the key. The key is name. The value is Alice. Key. This is another key, and it's separated by commas, right? So this is another key value pair. So the key here is age. Value is 25. So this is how it would look. Uh, and the lookup here is very efficient because it's all one. So the time complexity of it's very fast, constant time. Yep, constant time lookup. And yeah, I think collisions is kind of like an advanced topic and it's not really super common. So you probably, if you're preparing for interviews or something, that's not something that you would worry. Uh, Same, there's a link to the Python documentation of what kind of like methods and functions that you can utilize with um, dictionaries. And here we have a couple. I'm just gonna go through real quick. So by dict dot like dot get, it finds the key and returns the value of that key. So we don't have a key of city in our dictionary, right? So it's going to return the default value that you set here. So for example, if we um, if we don't have if we set the key here to name, it's going to return Alice. But if name is not present, is not in the dictionary, it's going to return unknown. Let me try and implement it real quick so that just you're following with what I'm saying. So we have the and it's a key value pair. So name, what did we name? Yeah, Alice and age 25. Name Alice. Mm, and then age, and then 25. So if I print, uh, yeah, print the, the get. So basically, I want to get the key, which is name. And if you don't find name, return error, for example, right? So we should expect it to return Alice. Let's see if that works, and it did work. It returns Alice. Let's try and remove Alice from the dictionary over here and see what happens. It returns error. You can say error didn't find the key, just to make it more descriptive of what the error is. Um, and you can default. This is just like a string that you put as default here, so you can put whatever you want to put. And let's go back to the slides. Oh, so yeah, you can access the value by printing mydict and passing in the key, which is basically something similar to what we just did. So if I do print mydict and then the value, which is age, and so that's also gonna uh, that is gonna yeah, that's gonna print 25. But the only difference between the get and this is that if the key is not here, so if I remove that key and it's just an empty dictionary now, it's gonna return an error, key not found error. Yeah, key error because it didn't find the key. So if you notice, the only difference here is that the code failed here and it threw an exception. But when we're using the get function or the get method, we were handling that exception by saying if it's not found, then return the string. And hopefully that makes sense. Back to our wonderful slides over here. Yeah, so keys must be hashable is like you cannot have duplicate keys in the same dictionary, right? So you cannot have two names or like the keys has to be unique. These are also like other methods, like the pop is gonna remove um like here update. Let's start with the update one. Update is gonna add this is another dictionary. It's update is similar to extend that we talked about in the list. So it's gonna add these uh, key value pairs to the original dictionary using mydict.update and then passing in the argument which is update. And or you could here it's the same thing, but it's just you're writing it descriptively inside the arguments. Uh, so yeah, when you do that, it overwrites also like so if you change the age here, it's gonna override the original value, which is because as I mentioned, you cannot have duplicate keys, so it's gonna just gonna find that key and override it with the value with the new value that you wanna override it. So age became 26 and it added the city New York. And then when we did another update, it added the country USA and the occupation engineer. But you can get the size of the dictionary using the length function. The values are the values that I talked about. This is a values function. It's going to get the values, just the values. So in this example that we have over here, the values are Alice and 25. The item is both the key and the value. Uh, any questions so far? Okay. Okay, cool. Uh, Iterables and iterators. So This is similar to the, like, if you have a list or a dictionary or anything or any kind of a data structure and you want to iterate inside that list and printing every single element, for example, that means that you're using some kind of a loop and a for loop, a while loop, or any kind of a loop in order to achieve that. And you have an iterable that iterates through the indexes of the array. So just to make it more clear of what I'm saying, let's get an example here. So back to our my list example. So let's say I want to print, so there's two ways here. Let's say if I want to print every single element, uh, print my list, and you're going to pass in the index. So that's going to print the first index, which is, what is the first index? Is one, right? So it printed one, right? Let's say we want to print all the elements, right? You know, when you do a copy and paste in code, you know that you're doing something that is not really optimized. And this is what I'm trying to explain here is I just copied and pasted everything and I changed one value, right? Which is the index. When I did that is, you know that you can always do something better or optimize it somehow. So this is gonna print in separate lines. This is gonna print uh, one. This is gonna print two, and so on and so forth. So one, two, three, four, five. And here, what you would probably do is a for loop. So you'd say for I, and I is your index in range. The range function gets the it passes in. Sorry, you're gonna do length. You guys want to get the length of the array and pass it to the range. So length is gonna return 5. So it's gonna be for I in range 5. That means that you're gonna go through from 0 to 4, and you can do print my list of I. That's gonna achieve the same exact thing that we have here. And just to make it more clear, let's type here separator, site buffer or something. Just so that you can see the output much more clear. So this is the first output, 1, 2, 3, 4, 5. This is the second output. We achieved the same result with just 2 lines here. Like, I don't know, 4 or 5 lines over here, and just 2 lines of the for loop. Yeah, I used the for loop range function, and you can do the same exact thing for the dictionaries and tuples, any data structure in general, like any data structure that contains multiple elements. Next we have sets. So sets are like they're mutable, so that means that you can change the value after you have it, but the sets cannot have duplicate values. So because they're hashable, right? I think it's written here somewhere. Yeah, they're hashable. That means that they can be used as like key. So as key, like hashables means that it has to be have a unique value, right? Uh, so you cannot have duplicates in a set. So that can be utilized in, let's say uh, let's say you have an array. And I'm trying to give an example of, okay, let's say you have an array, my list, and it has duplicates. If you change that to, so we have a lot of fives here, right? If you change that to, you can say my list equal, sorry, my set equals set my list. So basically what I'm doing here, I'm changing the list to a set, and we print my set. What we should get here is a set same as this one, but with no duplicates, right? Same as like with the same values, I mean, as the array here, the list that we have. And this is what we have, 1, 2, 3, 4, 5, right? Because the set removes the duplicates from, it cannot accept any duplicates, so it's gonna remove them, it's just gonna ignore them. Back to our slides. If you want to add more elements to the set, you'd use the add function or add method. So if I want to add 6 to my, let's say my set dot add, and then the add another element, then print, it's going to be 1, 2, 3, 4, 5, 6. And oh, clear, it removes everything. That's, I think these are also like some kind of useful. I'm not sure if you have access to these slides, but there is like, if you go through it, there's also some helpful information for that.
We have access, yeah. Thank you.
Okay, awesome. Uh, File handling, it's a lot written over here, but mainly the three things, I guess, the modes is read, write, and append. And these are the modes on how to open a file. The file could be like a text file, a CSV file, or like an Excel file. Like there's like a lot of like different uh, types of files, I would say. The main thing that the usually what I like when I'm trying to provide information here or like explaining something, I want to provide you with a use case. So when you open a file, you're just not opening the file. You probably opening a file to do some kind of uh, operations in the file. You're extracting data from the file, and you want to add these data together, or you want to, map them in a key value pairs, or you want to like utilize any of the data structures that we just learned. These are some kind of use cases for that. So I think here they're talking about the CSV files that we're just like we're talking. CSV is comma separated values, so like uh, the CSV file will have something like this, 1, 2, 3, 4, or like A, B, C. That would be like a CSV file, and then you save it as .csv. And a JSON formatted is like basically what we just showed you in the dictionaries, right? It's a key value pair, but it's way more bigger. So if you have the same dictionary over here and we add back name, name and job. So it would have more key value pairs, and inside those key value pairs, you could have another key value pair. So you can say something like uh, friend. Oh, wait. So the key is friend, and inside the key, you would have name, and then the which is another key value pair. And I just wait. Actually, I think if we go back to the slide, there was an example. Where was it? Give me a second. Oh, okay, never mind. I found something better. So So this is what I mean by like a key inside a key. Key value pairs inside each other. So you have a key and a value, key and a value. These are just keys and values over here. This is what JSON format means. And this is a key, and then you have another dictionary inside it with a key, and then another, and the value is a list here. And then you have the list has another dictionary inside it. So this is basically something more complicated using not complicated, but more verbose using dictionaries. Uh, Modules and libraries, like there's like modules and libraries help you utilize you have more usage for your code and your script, so you can get like an external library and import it inside the script. So for example, there's a library called request. So if I want to use that, I would need to do import, then the name of the library, requests, and then you use that in your code because it's already the algorithms and the methods and the functions are already implemented in this library. Instead of you implementing them from scratch, you're just utilizing this library and using the methods and the functions inside the library to implement it. Uh, then we have here, I think these are like, I'm not really sure how these are like key value arguments being passed like command line arguments. So instead of like running the script right now, we would have to provide some kind of arguments to the script so that it runs. And these are things for different operating. I'm just going through this really fast because I don't think it's really it's not really it's going to depend on what machine you're using, and some of them might not be relevant if you're not using because this is the environment values are being passed or the system module. So it could be it depends on the operating system that you're using. And I think here we have an example of passing in command line arguments. So this is the library argparse, and this is how you define a command line argument. So you the function main here has optional arguments and required arguments, right? So if you pass in the optional arguments, should like I think it's pretty descriptive that you don't really need to pass them, but if you pass them, they're gonna be handled. If you don't pass them, they're not gonna be handled. And uh, uh, yeah, if the required arguments, if you don't pass them to the script, it's gonna throw an error, or it's gonna tell you that hey, you need to pass this argument. It depends on like the message that you're passing here, right? So an optional multiplier, and these are the messages that would be prompted to the user in order to know what kind of arguments are required. Yeah, I think this is virtual environments, like how to set up a virtual environment, and uh, virtual environments are like useful because if you're gonna if you're working on multiple scripts or multiple applications or multiple code, and you want to have specific libraries or modules in that specific script or that specific environment, and you don't want all the environments to be to overlap, that would be the useful use case for the virtual environments. A useful use case for the command line arguments is that you want to force the user, or you want to validate the arguments passed, the input passed by the user So that would be a good use case for command line arguments. And what else? The Q&A and demo, basically, the demo is just like what I've been doing throughout the session over here. So I'm gonna open it up for questions. If you have any questions about what I mentioned or any slide that I talked about.
Hi. You said that you work currently as a site reliability engineer.
Yep.
How long have you been working, and do you use Python at work a lot?
Yeah, so I'm working as a site reliability engineer. I've been working for my current company, which is Paycom, for around 2 years. Um, so a site reliability engineer is what I call, just let me give you like a brief intro on the role, because it's not popular for everyone. I would say not everyone rules the role, but what I would say it's a 50-50 role. By 50-50 means, I mean 50% troubleshooting. So you basically troubleshoot issues related to production. Let's say the application is down, the user is not able to uh, do the expected use case, or the expected behavior is not happening. We troubleshoot that and we try to understand what's wrong in the code. So we try to identify which line in the code or which function or which service is being impacted, and then we try and fix that. Or we engage, if we cannot fix it, we engage the developer who actually wrote the code to push out a fix for that. The other 50% of the job is automation. So in my job, I'm using Python, I'm using PowerShell, I'm using Bash. Also, we're writing these scripts to automate processes. Like let's say if there's a manual task that is repetitive. So in general, anything that is manual and repetitive can be automated, right? Same like the very simple example that I showed here is if you copy and paste the same exact thing, then this is considered automation, right? Or optimization, I would say. Um, so yeah, so just to answer your question, it's basically I use Python, I use PowerShell, and I use Bash scripts also sometimes. Those
I
are
see. Thank you. Thank you. I'm actually interested in the site reliability engineering, and I kind of want to pursue that one too. Like if and that's why I'm learning Python for that reason too. And are you available like for one-on-one mentor through Code the Dream, or you just give a group lessons only?
So usually I'm just with the group sessions, but we can schedule something if you want to talk more on site reliability and because another part of like you can you are you on Slack?
Yes, yes.
Okay, just
Would be great because I just wanted to get some career tips or advice if you're in this field, you know.
yeah, absolutely. Just hit me up on Slack and shoot me a message, and we can schedule something to talk about that more in depth. Of
Thank you.
course. Any other questions or comments or anything? It doesn't have to be like related to what we're talking about. It could be about anything. Okay. Uh, Taking the silence as a good sign. Uh, that everything is clear. Um, oh wait, I see a message. Okay. I didn't, yeah, probably should have zoomed in a bit. Yeah, thanks for the, um, awesome. Okay, thank you all. I think we're probably gonna wrap this up earlier because I don't think we don't have any questions, and I finished up what I was planning on finishing up. Thank you all for joining, and hopefully I'll see you next week. Take care and enjoy your weekend. Bye.